Hi, everyone. Welcome to today's Tech Talk, Modernizing Your Data Platform for Analytics and AI in the Hybrid Cloud Era. My name is Regina, and I will be your moderator. Before I introduce our speaker, I have a few housekeeping items. All participants are automatically on mute throughout the session. Also, we will be using Slack for Q&A, so we invite you to engage with us in the open source community on our Slack channel, which is alluxio.io/Slack. If you have any troubles joining, feel free to message your questions via the GoToWebinar control panel located on the right-hand side of your screen. In today's session, you'll hear from our presenter, followed by a Q&A session at the end. Again, to ask a question, join our community Slack channel, which I posted into the chat box here. Please don't hesitate to send in your questions anytime. No need to wait until the end. Lastly, today's session is being recorded and will be available for on-demand playback. A link to the presentation will be emailed to you as well. I believe that covers all housekeeping items, so let's go ahead and meet our speaker. I'm very pleased to welcome Adit Madan.
Hi, everyone. In today's session, I'm going to talk about a few options to consider when you're looking to modernize your data platform, both for analytics and AI. Before we begin, a little bit about myself. I am Adit Madan. I'm a project manager at Alluxio, the company. I've been with the company for the last 5 years, and I'm also a member of the project management committee for the Alluxio open source project. Some context on why we built this solution for Alluxio. We saw that a few years back, we had only one large Hadoop clusters as the standard for an analytics platform. We had compute and storage co-located on the same cluster, but we've come a long way from that now. There were many problems associated with an architecture in which compute and storage are co-located on the same cluster. Clusters were compute bound and overutilized. To tackle these problems, we moved from a co-located architecture to a disaggregated architecture. In this disaggregated architecture, initially people started using HDFS as a centralized data lake with multiple different compute clusters, but this on its own had many different issues because HDFS wasn't designed to be a solution for this architecture. Now, since then, as most of you know, we've come a long way. There have been a lot of new compute frameworks which have come along, which are specialized and better suited for a specific kind of job. You could think of Presto for BI, Spark for all the way from ingestion BI with SQL to machine learning. And similarly, on the machine learning side, we also have seen recently the use of TensorFlow and PyTorch as applications, both inside a single data center, but also across data centers. HDFS, even though was the standard in the past for an on-premises data lake, people have started to migrate from an on-premises data lake to a public cloud. And during this migration, sometimes data resides in the on-premise data store, but there is a need to burst into the cloud and access data which used to be on-premises. And similarly, HDFS has now been replaced in many cases by an on-prem object store or an object store in the public cloud. Alluxio, the system, was built to tackle a lot of the problems that come along with the separation of storage and compute. As you all know, data has gravity, and moving data across many different environments or many different clusters is not an easy job. Alluxio sits as a new layer between different compute frameworks, be it analytics or AI, and many different storage systems. It's a platform which is supported in many different clouds. All popular cloud providers support Alluxio, and Alluxio can also be deployed in containerized environments such as Kubernetes. Like I was saying, Alluxio is a new layer which we term as data orchestration. Data orchestration sits between different compute frameworks, which you see on the top of this picture, and different storage systems that you see at the bottom. Alluxio, what it does is manages data movement across various different systems that you see in this picture. Alluxio can move data based on data access, such as when Presto is accessing data which is residing in a cloud store. Alluxio would be able to fetch that data based on access and optimize it for the access pattern. Or Alluxio also has the capability of moving data based on policies. And I'll explain a little bit about what that means. So you could think of use cases with Alluxio where we have a migration of data across the different data stores based on certain policies, such as access times. Alluxio as a system sits between these different compute frameworks in different steps of a data pipeline. You can imagine a data pipeline as a combination of different compute engines, such as Spark for ETL, then moving on to Presto for BI, and TensorFlow for some AI. In this kind of an environment, different frameworks talk to Alluxio using different interfaces. Presto and Spark, for example, which are Java-based applications, they talk to Alluxio using the Java HDFS API. And similarly, if you move on to the AI space, a typical way to communicate with storage is using the POSIX interface, which is a file system interface for native applications to talk to Alluxio. On the bottom of this picture, you can see that by having this virtualization layer which sits in the middle, applications are no longer tied to the storage API itself. Alluxio translates from the compute API to the storage access API transparently to the users. Now, this system is used in a variety of scenarios. There is a need for data orchestration, especially when a data platform expands to be a global data platform, which comprises of multiple private data centers, but also multiple regions in a public cloud. For such a scenario, we typically have an instance of Alluxio co-located with every compute cluster. So whichever cluster needs access to data which is separated from the compute cluster would have an instance of Alluxio. In this picture, you can see that when we have Alluxio deployed in AWS, the compute applications in AWS are able to access data which is residing either in AWS S3 as the data lake or on premises in an HDFS data lake. So you can imagine Alluxio as being a unifying agent for multiple different data lakes, which you could have spanned across multiple different regions. The journey for a user to get to a stage like this is obviously made of a couple of, obviously starts very simple. We see people adopt a solution like this using a sequence of steps, which I'll talk about in the next few slides. And you might find yourself not having the problem of multiple data centers right now, or you may be in a single data center, but you want to prepare yourself for some kind of migration to the cloud. So that's what this talk is about. I'll kind of outline a few sequences that we've seen commonly our customers and users take so that it would be easy for you to possibly make a similar journey in the future. The two use cases that we see on this slide are two typical examples of how a user gets introduced to Alluxio and the value of data orchestration. The first use case you can see is with TensorFlow, but all of the compute frameworks which I have in the next 2 slides can be changed with any other compute framework. In the context of a single cloud, let's say we are using expensive GPU instances and it's accessing data which resides in object storage, which is not co-located on the same cluster. We have Alluxio as co-located with TensorFlow, feeding it data so that the compute is not bottlenecked on data access. For a scenario like this, what we see a user benefit from is consistent SLAs that each iteration of the job doesn't really have any variance which is associated with a remote storage solution. We see performance benefits because of the caching aspect, which is part of Alluxio's solution. And we also see cost savings on a cloud object store, which charges you based on how many ops do you perform on the store itself. The equivalent of this on-premises is when we have these different on-prem object stores, such as Cloudian, CleverSafe, or Ceph. We see Alluxio being deployed on each compute cluster, which needs access to the centralized data lake or the centralized object store. The benefits are similar to what I described in the context of a single cloud. We achieve isolation per cluster, which may be catering to a single business unit within an organization. The next 3 cases that I have, these 3 use cases are spanning multiple different locations. The first one is what we call a hybrid cloud use case, in which compute resides in a public cloud, whereas storage is residing on premises. So we've seen people use this solution when there are certain regulations, for example, which prevent data from being moved permanently to a public cloud, or just when people don't want to duplicate data in the public cloud and be tied to a single object store solution by a specific cloud service provider. For situations like this, Alluxio is, like I described before, co-located with the compute engines, which could be Hive or any other compute engine which I mentioned. Data is accessible on demand for the compute, which could be ephemeral in the cloud. So we could spin instances up and down as needed while accessing data in the cloud, in the on-premises data center, without incurring the cost of repeated data transfers between the on-prem location and the public cloud. Similarly, it's not a solution limited for read caching. It's a solution which also has abilities for write caching. And in the context of this first hybrid cloud use case, which I'm talking about, write caching means that you don't incur the cost of network egress from a cloud provider, as only the data that needs to be, the final data which needs to be propagated back to the store on premises actually gets moved. The second hybrid cloud use case, which is the center of this slide, is where we have on-premises Alluxio accessing data in a public cloud. Now, this scenario is important for people when they've already made the journey into the cloud. They're well into their cloud migration, but there are still on-premises resources such as CPUs and on-premises machines which are using the same data, and they want to preserve their investment in the on-premises data lake while still migrating to the cloud to adopt the benefits that a cloud provides. Now, for a scenario like this, Alluxio is also like before, co-located with the on-premises cluster, and the GPU applications or CPU applications on premises would use Alluxio to access data in a public cloud. In this case, the benefits of caching on the read path directly translate into cost savings for our users who would save on network egress costs. And data does not need to be moved or synchronized as they are changing on either end of this picture. The third case on this slide is a multi-data center use case in which Alluxio is deployed in one data center and it's accessing data which resides in a different location while it's being mutated in a different location. Now, this scenario we've seen is when a big organization has excess compute capacity in one location, which needs access to data which is primarily residing in a different data center. That's the use case which we call cross data center access. In all these three scenarios, ingest ETL pipelines don't need to change at all, while you're able to move one step of the pipeline, which could be analytics or AI, to a different location, be it in a separate data center or a separate cloud. Now, the three key innovations of Alluxio as a system are listed on this slide. The first one is that Alluxio really unifies different data lakes. In the past few use cases that I talked about, Alluxio unifies different storage solutions such as S3 or HDFS. So this is the aspect that we're calling unification. Multiple different compute frameworks are able to use multiple different storage systems with this abstraction without really the need to move any applications or to change any applications to be able to use different storage systems. The one in the middle, it's all about efficient access to data, and caching is a major part of this. When you have the separation of storage and compute, Alluxio caches data close to the compute so that repeated accesses of the same data are able to benefit from the locality that Alluxio provides with the caching aspect. Alluxio manages certain tiers of storage on the instances close to the compute to be able to provide these benefits. The third one is that Alluxio allows you to architect your platform in a way which is agnostic to a specific vendor. So like I said, a common way of architecting such a solution is to have Kubernetes as a compute orchestration and Alluxio as data orchestration. By having these two layers of abstraction for compute and data, the architecture is portable across both on-premises and multiple different clouds. The next few slides, I have a few examples of a journey that different customers have taken with Alluxio. The first example is an example of a customer who's been with us for a long time now, and the journey started very simple. The journey started in the context of a single data center where HDFS was being replaced by an on-premises object store. The first use case for Alluxio in this case was the unification aspect, in which Alluxio acted as a unification layer for data which resides in two different storage solutions. By having a unified namespace, Alluxio provided a single point for data governance, such as access control policies could be set at a single layer, and applications only need to talk to Alluxio regardless of the location of the data, be it in HDFS or an on-premise object store. Now, when HDFS was replaced completely by the object store, there was still a use case for Alluxio in the context of a single data center, in the sense that Alluxio was accelerating analytics on top of an on-premises object store. So what you'll notice in this slide and the next is that by having this abstraction layer, it gives you a lot of flexibility into how you design your data platform and how do you future-proof your application for architectural shifts over the upcoming years. Now, by having Alluxio in the middle, what happened was that people, when they made the shift from an HDFS storage solution, which was co-located with compute before, to an on-premises object store, the experience was very consistent. Application performance did not change. Applications, the way that they were written, did not change. But under the hood, HDFS was now replaced with an object store. The third step in their journey was the first hybrid cloud scenario, which I had described in a couple of slides back, in which we saw that there was a desire to burst certain compute capacity to a public cloud without moving all of the data from the primary data lake, which is an on-premises object store, into the cloud. By having Alluxio, we were able to provide data access for compute in AWS to the on-premises cloud store. Compute in this case was a combination of managed Hadoop, Kubernetes, and also cloud-native AI applications for model training. The last step is after one cloud was adopted, we see that we were able to replicate this same setup on a second cloud. And this is because of all of the abstraction which I talked about in the a couple of minutes back, where we have Kubernetes as the primary compute abstraction and Alluxio as the primary storage or data abstraction. So this whole data platform was portable across multiple different clouds. And this is something that we've seen across all of our users, where they don't want to be locked to a single cloud provider. So having the flexibility of moving when they choose across different cloud providers is actually a very big deal. Now, this is how the journey looks like in terms of an architecture diagram. We initially, like you see on the bottom side of this picture, we have a private data center. There were a combination of different applications for analytics, Hive, Spark, and Presto. And every step of the data pipeline, including ingestion and ETL, talked to Alluxio, Alluxio was the only system which accessed the on-premises object store. Now, once we move to the clouds, you can see that there is an instance of Alluxio for every region in a cloud which needs access to data, which is not co-located with the compute engine. Now, the second example is a little different. For the second example, the first step that this particular user took with Alluxio, or this set of users took with Alluxio, is actually when there is a need to burst compute. So they're kind of starting at step 2 of what I described in the previous slide, where there is data residing on premises, but there is a need to burst compute. So the aspect of data caching and efficient representation of data was the primary use case. Now, after using Alluxio as a system which is enabling hybrid cloud, there was a need to also support high availability of the system. And high availability in this case means replication of data across multiple different storage systems, such as HDFS and a public cloud store across multiple different data centers. Now, by having Alluxio as a system which sits between the ingestion pipeline and replicating data at ingest across multiple different systems, the rest of the pipeline we were able to replicate the rest of the pipeline all the way from ETL to analytics across multiple locations for a high availability. Similar to the previous case, the abstraction was used to go eventually to a multi-cloud model where the same stack of software, including compute and storage, was replicated across multiple CSPs. So if you look at the architecture for this example, we saw the initial use case was Azure Kubernetes accessing Alluxio to access on-premises HDFS. Now, if you look at the block on the bottom left corner more carefully, you can see the green ingestion block. And once data was being ingested in this private data center, Alluxio is actually replicating the data across multiple different locations. You can see the green arrows going to the HDFS location in data center 1, but also the same green arrow going to the HDFS location in data center 2. What this is representing is that Alluxio is capable of replicating data across multiple different storage locations. Now, in the rest of the presentation, I'm going to start describing a few core features in Alluxio which enable the hybrid data lake solution that we talked about. The first one, the first major one, is caching. So Alluxio as a system manages different tiers of storage, both it could be RAM, could be SSDs, it could be spinning disks on the cluster where Alluxio is run. Alluxio is a distributed system. It has different processes which you need to launch, which reside alongside your applications such as Spark or Presto. Now, when these applications access data which belongs to a remote data store, Alluxio manages this Alluxio managed storage across multiple different tiers transparently to guarantee performance is the same as if data was local on those same machines. Similar to data locality, Alluxio also provides metadata locality with consistency. What I mean by metadata locality is that Alluxio has a copy of the file system or the object store namespace that you might access using Alluxio. So if you have a combination of Spark and Presto, accessing Alluxio, accessing an on-premises object store, or on-premises HDFS as we see in the system, Alluxio clones the metadata from HDFS and manages that metadata on component, which is the Alluxio master. Now, when things change under the hood in HDFS, Alluxio is notified of these changes so that this metadata clone that we had is actually consistent with the metadata in the underlying storage system. Two more ways of moving data in addition to caching, which is access-based movement of data from an underlying store into Alluxio managed storage, are represented on this slide here. The first one, we call it a distributed load operation. What this does is that you are able to asynchronously load data from an underlying storage solution, such as HDFS, into Alluxio managed storage. So the blocks or the files that you see in the bottom of this picture, you could issue a command in Alluxio when the ETL job finishes. We want the partitions or certain data which is added or representing the newly added data for the last couple of hours to be loaded into Alluxio. So this is a way of warming up the Alluxio cache if you know that this is what is going to be accessed in the future, which is a typical way that we've seen people use the system. Now, what you see on the right-hand side of this picture is caching, but caching for the write path. So for the hybrid cloud scenario that I was describing before, in which compute and Alluxio resides in a public cloud, but data or the final data store resides in on-premises or a remote location. Alluxio also provides caching for the write path. This is something that we call fast durable writes, in which when you write data, Alluxio holds the data temporarily until the data is persisted in the background to the final store. Now, since Alluxio is located closer to the compute, this write to Alluxio is much faster than the write to the underlying store. And only data the final data that needs to be persisted is actually written to the eventual store. So for write-heavy workloads on top of Alluxio, we see significant performance benefits using this feature, which we call fast, durable writes. Now, what I have on this picture is actually demonstrating a very powerful concept in Alluxio. As you know, Alluxio has a file system namespace. Each section of the file system namespace can represent a certain section of an underlying storage system, which could be one or more. The root of the file system namespace is pointing to the storage system on the right-hand side, which is one instance of HDFS. You can see that HDFS, one in yellow, has directories called users, Alice, and under that Alice and Bob. The users directory is inherited by Alluxio at the root of the file system namespace. But if you look at the directory, which is data, data is actually backed by multiple different storage systems. You can see that data is backed by one HDFS on the one instance of HDFS, and also it's backed by an S3 object store. What this means is that when you write data into this new location, you can set policies in Alluxio saying that I want this data to be written to one or both locations. And at the same time, when you read data from this location, you can set priorities in Alluxio saying that when I'm reading, I would want to read from the data store which is closer to me. And at the same time, you can also set policies which are executed asynchronously to migrate data from one location to the other while the migration is also live. So your applications are not impacted at all while there might be movement of data in the background. Your application would continue to access the same path in Alluxio regardless of the location of the data itself. Now, this slide is looking a little deeper into when you have certain applications which are used to talking to an HDFS location, and how do you start using Alluxio? One problem that we've seen users face is that they have large amounts of metadata in a catalog such as a Hive metastore, but the Hive metastore is pointing to an HDFS location to begin with. Now, when you want to use Alluxio for this picture, or for this scenario, we don't need to change the locations in the Hive metastore itself. Alluxio, by the matter of a few configuration changes, we are able to point Hive and Presto to use Alluxio for HDFS URI itself. Now, in this scenario, what that means is that you don't need to change anything in your Hive metastore by this feature, which we call transparent URI. You're able to access data which was in HDFS, but it's going to be served by Alluxio, and it's going to be cached by Alluxio, and you'll see all of the benefits that I talked about in the previous slides by having this system, by using this feature, which is called transparent URI. That was my final slide. As you all know, Alluxio is an open source project. It came out of the same research lab as the Spark project did, which is UC Berkeley's AMP lab. We have been ranked as one of the top 10 critical open source Java projects by the Google Open Source Foundation. We have a large amount of contributors, and that list is growing continuously as well. We have a mix of users and customers across many different industries, and a few major industries where we see good adoption for Alluxio are listed on the slide over here. That was the quick overview of Alluxio. If you guys have more questions, I'm happy to answer them now.
Thank you, Adit. Lots of great information. And I can see that we do have a couple questions here. As a reminder, if you do wish to ask a question, please join us on Slack or feel free to message questions through the GoToWebinar control panel. Our first question, does Alluxio work with machine learning?
Thanks, Regina. Yes, Alluxio does work with machine learning. We've seen the use of Alluxio across multiple different steps of a machine learning pipeline across the data preparation phase, where we've seen the use of Alluxio as being able to cache data close to the GPU instances when the data is being pre-processed and the data is being cleansed. And at the same time, we've seen that machine learning is also a very iterative process where you access the same data multiple times to train your models. So also in the model training step, we've seen the use of Alluxio co-located with GPU instances typically used for this model training step of a machine learning pipeline. So we have seen a good amount of use of Alluxio for machine learning as well. And we've seen the use of frameworks like TensorFlow and PyTorch as trending upwards specifically for machine learning.
Great, thanks, Adit. Next question, does this have advantages in non-hybrid cloud configurations?
Yes, so in the context of a single cloud or a single on-premises use case, we do still see value from Alluxio. In one common scenario for on-premises data centers we've seen is that once the data lake, which could be HDFS or an on-premises object store, gets extremely overloaded, we are able to guarantee strict SLAs and also performance benefits depending on the application, all in the context of either a single cloud or a single data center. And at the same time, once your organization grows past a single data center or a single cloud, we kind of prepare you for hybrid cloud. But that's the value is not limited to this hybrid cloud or a scenario where you have multiple different data centers.
Got it. Next one, this individual has a large number of tables and schemas defined. How would they configure Alluxio to work with their existing metastore?
Got it. So for this one, the feature which I talked about, which is called transparent URI, that feature is very relevant to this case. So the configuration for this would look like there would be a few properties that we would set in the Hive metastore or whatever the catalog is, and also the compute engine. So the example that I had in the previous slide was that we are using Presto as the compute engine, but this could be Spark SQL or any other compute engine that you're used to. Now, by a matter of configurations in both the catalog side and also the compute engine side, be it Spark SQL or Presto, we would be able to use Alluxio without changing any location.
Awesome. Let's see here. We have one other question. Again, if you do have any questions, feel free to message us in the GoToWebinar platform or our Slack channel. But one more question here. Does Alluxio help accelerate things like Snowflake or Redshift?
No, for Redshift and Snowflake, Snowflake is a closed solution and Alluxio does not integrate with Snowflake. And for Redshift, Alluxio is a solution which is limited for SQL or AI workloads, but does not act as a general purpose acceleration layer for key value stores or other more specialized systems like Redshift.
Got it. That looks like all of our questions here. Great. Well, thank you so much, Adit, for hosting today's Tech Talk, and thank you to our audience for joining us today. This concludes our Tech Talk. Have a great day, everyone.